Welcome to the last GSE, virtual GSE day and the penultimate CICS session. We've got Steve and Joe here from IBM who are going to do a presentation on BTP, and they'll tell us what that stands for because I've forgotten. Just a quick reminder, at 10:30, we've got all the good and the great from Hursley coming along from a Q&A session. So if anyone has questions, not that we haven't got loads, or we haven't, to stump the panel of experts, prizes will be given out, virtual prizes, unfortunately, but that would be much appreciated. If anyone's got any questions during this presentation, I know Steve and Joe are experienced presenters, and you're all on mute. If you can just pop them in the chat, and Nick Garrett or myself will pick up on those and interrupt the presentations at a convenient point to ask your questions. Steve and Joe, I hope you're okay with that, because we didn't discuss it in the last 5 minutes. But without further ado, Steve, take it away.
Yeah. Okay, thanks, Rob. Morning, everyone, and welcome to I think it's the penultimate session in the CICS track this year. I'm Steve Foley. I'm the IBM CICS rep for UK and Ireland, and I'm joined by my colleague Joe. We're going to co-present today. Joe specialises in DevOps and Z and modernisation of the mainframe. The background to this session is a POC, a proof of concept. Joe and I were involved in earlier this year. A customer had a requirement to automate the testing of their CICS transactions and to include those automated tests in a CI/CD pipeline, so that when the programs were being released through to production, the CI/CD pipeline would include CICS transaction testing. Quite an interesting requirement, and it coincided with a new tool that's been developed by IBM called, and this is where you get to know what VTP stands for, IBM Z Virtual Test Platform. Now, amongst other things, this is not just a specifically CICS tool, this is an IBM Z tool, but amongst other things, what this tool does is allow you to record CICS transactions and store the inputs and outputs for every program in that transaction for later reuse, so that when you come to replay that CICS transaction, you can replay it without needing a CICS region, without needing a database or other middleware. And although we'll execute your COBOL, PL1 and assembler programs, it will compare the inputs and outputs to those programs when they're replayed with what you recorded earlier. So again, quite an exciting piece of technology. Now, this customer is a customer I'd worked with for many years, and I knew something of their CICS environment. And I have to say, my initial reaction was, this is never going to work. There are too many complex and historical facets of this customer. This product, which at the time was version 1.1, I was convinced would not be able to support. And I have to say, and this is the reason for this presentation, I was completely taken by surprise where time after time this product stepped up to the mark and supported things I never imagined version 1.1 of a product would support. So the agenda we have laid out is, Joe's going to start and he's going to give us a brief introduction to the product itself, IBM Z Virtual Test Platform. And then I'll talk about some of the challenges I've just inferred. How did this product manage to successfully record this customer's CICS transactions with some of the complex variables at play? And then the bulk of the session we're going to leave to the end. Joe is going to give us an end-to-end demo of the product, through recording in CICS to playing back in VTP, and quite a kind of revolutionary concept that Joe himself has developed. He will show us how to debug a CICS transaction without needing either CICS or DB2. He's getting some great reaction to this demo. For just yesterday, I think he was telling me a customer literally told him he'd blown his mind. I don't think he meant he literally blown his mind, but he told him he'd blown his mind. Okay, so with that, I think I'm going to hand over to Joe now, and you can take us through an introduction to the product itself. Over to you, Joe.
Okay, yeah, thanks, Steve. So hi, everyone. As Steve introduced me, Joe Taff-Atkins. I've been working on DevOps in Z for a few years now. And this is one of the products I've picked up because we can finally embed mainframe testing into a pipeline, right? Which is DevOps is the thing that everyone's talking about, everyone's trying to do in order to deliver faster to the market. So ZVTP, or Z Virtual Test Platform, is really what Steve said. It allows users to, or development teams to record and then replay those mainframe transactions, as well as batch applications. So it's not just limited to online applications in a virtualized environment without the need for middleware or data, right? So the methodology that you would undertake is that you would record your original transactional journeys or application journeys. So you have to still have an environment where you can record these sort of journeys that you want your developers to test against after they make their code change. So you preferably want to record in an environment where you've got good data and you've got good interactions between the applications and so on. We do have processes to record from both batch and online applications. So the idea is typically before a development feature has been worked on, let's give an example. We want to change the interest rate, right? You would record all those transactional journeys for that interest rate and then let the developer make their change, and then they can replay those transactions afterwards, right? So that's the sort of the way it would work. And that's just one use case. So once you've done your recording, the second thing is to then distribute that recording, which is essentially just a sequential file, to your development teams and your developers. Then the developers, as I said, will make their code change in line with the feature or the emergency fix that they're working on. So you'll follow the same practice that you'll typically follow when you're code making changes today. We're not trying to interfere with that practice. The third step is then you replay those applications plus the developer's modified programs, and that is in batch, right? So there's no online, no data, no middleware required at all, right? Now, when you replay, you might have mismatches between the recording and what you've changed and after your change, before change and after change. You might have some mismatches, right? So the key thing is, you will see mismatches at a program-to-program level, to program-to-subsystem level, because we record the program-to-program calls, program-to-subsystem calls, even the input into the application or the transaction. But then the developer's got this insight, he's got this view that, okay, I've seen there's a difference now because of COM area, I changed the COM area structure, therefore there's a difference. But now the developer can quickly validate, to the fourth step, the developer can quickly validate if that is the desired behavior based on their one program change, or is not the desired behavior. If it is the desired behavior, then great, thumbs up, job's done. You can promote the code to your integration test environment and do a full integration test, or as you normally would do. If it's not the desired behavior, then great, that report will show me that, hey, there's a mismatch between program 10 and 11. And I can say, oh, I didn't expect that based on my code change. So I can pick up the phone and talk to that developer who's worked on that program or whatever, and say, I basically get that quick insight to understand if my code change has done something weird to the application further downstream, and I can fix that immediately in my dev environment. So the benefits are. Well, I think the benefits are quite astronomical in my mind, because you're shifting testing much early in the development lifecycle. And you also are increasing you're increasing your test execution throughput, because I'm now able to test continuously without having to worry about the middleware and data. Now, this capability might not work for all types of code changes, but for the ones that it does work, I can do more test execution throughput. I can identify unforeseen effects of my program change, right? So I've changed my one program, but then I can quickly see that, oh, that one program change has caused some unexpected behavior in program 2 or 3 or 4. The third one on the screen is it allows a larger test of other transactions and programs in the process. That's probably not the best way to describe that, but what that means is, even if you don't know the call hierarchy or the transaction conversation, those programs or transactions will be recorded and replayed. So if there is a downstream effect from a change made, it will show up in the replay, even though you may not have explicitly intended to test those programs or transactions. Now, one could limit the recording. You can limit the recording to a set of transactions and programs, but that's the user's choice. And ideally, you want to make that choice in the test planning phase before you actually start your development work. But the idea is that you get test coverage of artifacts you may not even be aware of or aware are involved. You can do unhappy paths as well. So you can record unhappy paths within the transaction or the application and then store that as a recording, as long as you can simulate those scenarios in a test or pre-prod environment. The recordings can be committed to a CI/CD pipeline. So something I won't show in this session, but I can store that recording, that flat file, in Git. So imagine that all that recorded data can be stored in Git, and then I can then distribute that to developers to then run that transaction anywhere they want. Their own personal sandbox environment, their own, a shared developer, whatever. The replay can happen on any ZOS platform. So just to re-emphasize my point, or our point that we're making, we're going to run a replay on a ZD&T environment running in OpenShift. And in that environment, we've got no CICS, no DB2 setup. And the reason why we want to show that, because I believe it can really strengthen the proposition of giving developers their own sandbox environment, because you're essentially virtualizing that middleware that can then be deployed and run anywhere, right? And there's no data refresh processes required at all, because all the data is captured in the playback file. So usually what happens, developers run their tests, then they have to reset the data, then they run their tests again. I don't have any of that waste of having to reset data, because all the data is hard-coded in the playback file. Okay, next slide, please. Okay, so what changes does a user need to make? Next slide. Absolutely nothing. And this is why this product continues to amaze me. Whether I'm working for IBM or not, I just quite simply record, I replay, and then eventually I have to test for real, right? But the idea is I'm replaying, and I can identify any integration issues much earlier in the process without having to faff around with data and all that sort of stuff. And it does work for any supported version of CICS, DB2, IMS, MQ, assembler, COBOL, PL1, right? So it really is quite amazing technology. So this is a quick slide how it works. So essentially, you've got 3 stages. You've got what we call the collection phase, right? So this is where you trigger off the recording. There's different types of ways of recording, if it's batch or CICS or LMS. When you trigger off the recording, you would run your user applications as you typically would do. And when you run your user applications, you're running specific application journeys that pertain to the code change or the emergency fix that's about to happen. The next is then all that recorded data is stored in a playback file, right? So question I always get, is it real data? Can I see the data in that file? Well, the data in the playback file is binary and it is compressed. And the compression algorithm which is relatively straightforward, it is proprietary to VTP. The general rule with the playback file is that the program won't be satisfied if new data has to be present after the code change. So you just have to keep in mind, this practice is a great practice, but doesn't work for all code changes. For example, if I'm going to add a new column to a DB2 table, or extend the size of a VSAM file, then maybe this won't work. But 60% of the time, 70% of the time is still good enough, I think, to reduce the overhead of resetting data and middleware and shared environments and so on. And then I can replay. So I can then replay, but the key thing is we are replaying the application load modules only, and we're simulating CICS and all the other middleware stuff in order to validate that we haven't caused any unexpected behavior in the programs within that application, right? And now that opens up the door to a whole wide range of things. I can run my tests in OpenShift. I can run them in, which I'll show you today. I can run them in ZDNT. I can run them in on-prem on the LPAR. I can put it as part of a pipeline. Several things you can now do. Okay. So I'm not going to profess to know that I know all of these all of these calls, but I just thought, because it's a CICS audience, you're probably much more well versed in CICS than I am. But we've put a link, a list of all of the types of calls that we can record and capture and store. And on the left, you can see we've got a few things around CICS. I've put IMS and batch there just for your reference. But this is a slide you can go into a bit more detail after the session. So again, I know this is the CICS audience, but we've put this slide here just to show you the sort of process that you'd undertake. So I'll just talk to the CICS one for now. So essentially, there's a transaction that you trigger off, and then when you trigger off that transaction, you can start recording. The recording can happen in two flavors. You can record from the terminal screen, or you can record from an incoming transaction into that region. So for example, I can say, start recording CSMI, right? That means I'll record any ZOS Connect calls coming into that region and at that time. Now you do have to consider, you don't want to be recording in an environment where it's extremely busy. You do want to make sure you time when you record and think about that. But once you do start the recording, all those program-to-program calls, etc., will get stored in the VSAM file, which is under CICS. And then you use another transaction to obviously end the recording. And there's a transaction to write that recorded data out to a TD queue. You then stop the TD queue, copy that TD queue, give it a meaningful name, and then you can store that data in Git. You can distribute that out to your developers by just telling them, here's the sequential file, go copy it and do your testing. Or you can deploy it to an environment using a deployment manager to ZOS, ZDNT, or wherever sandbox environment you're running. Yep, I think that. Oh, and optionally, you can record the PLT and PI, which I think Steve might touch on. Okay.
Okay, thanks, John. Joe, just pause there in case there's any questions before we move on.
Okay. None so far, Steve.
So, and I'll just take a small amount of time now just to go over what some of the reservations I had, I'll be honest, about the product beforehand, and some of the things that ultimately surprised me about what the product was capable of. So just to reiterate what some of Joe has just covered, the recording process in CICS takes place at global user exits, and 1, 2, 3, 4, 5, 6, there are 7 global user exits that VTP uses to capture the inputs and outputs. Those of you familiar with the glues will recognize them, but essentially basically in and out of any exec CICS command, in and out of the resource manager domain, and in and out of the DL1 process. as well as the XPC fetch exit, which runs every time a CICS program is executed. So you can see right away how VTP is collecting the inputs and outputs for each program. The recording process, the recordings themselves are stored in a VSAM file, and that VSAM file essentially will contain all the recordings performed by every user in that region up to the point that the user decides to write them out to a playback file. The playback files are sequential files and they're defined as TDQs in CICS. By default, there'll be one playback file defined to CICS region, but if you want, you can define multiple, just define multiple TDQs. You can have as many as you want. The global user exits points are not enabled until the recording starts. So be assured that VTP is not running unless there is actually a recording in process, and the glues will be disabled when the recording ends. Now, that's all very well. So that's how it works in a single CICS region. The first question that occurred to me with this particular roast customer, well, that's very well, but their applications run in a CICSplex, and programs which are in different regions, DPLs, etc. So my initial assumption was VTP would not be able to handle that, and so this was the first surprise for me, was it actually does. So here's an example of a CICSplex, and in this example we would have programs in the TOR DPLing dynamically to other programs in the AORs. So VTP actually has the capability to intercept the dynamic routing programs. That was, I don't know whether I was impressed or aghast when I discovered this, but the fact is it can intercept a dynamic DPL and ahead of time start recording in the target AOR before the target of that DPL actually executes. So it can in fact record both the calling and the called program, even if they're in different regions, and record them to the same VSAM file if you define the VSAM file for example, in a file owning region. So that was the first surprise. Other surprises which occurred to me was, so Joe's already told us VTP supports all exec CICS commands, FEPI accepted. It supports DB2, DL1 and MQ calls. As I've just said, it is able to record and play back DPLs. So here's another number of things which I thought a version 1.1 of a product would not be able to support, but in fact it does. COBOL calls, how many times have I had a customer ask me whether a product X, Y, or Z supports COBOL calls, and the answer is usually not yet. Well, from the get-go, VTP supports COBOL calls, and that's both dynamic and static COBOL calls. It can intercept the inputs and outputs. Some older techniques, and this particular customer had like many customers, had applications going back 30, 40 years, and they were using other techniques to pass data between programs. So what constitutes the inputs and outputs for a program is not just what's in the COM area. It could be data that's stored in the transaction work area. It could be data that's acquired via get main shared. Different transactions and programs can communicate via all sorts of shared storage. The CWA, TCTUAs. This product has from the get-go the capability to intercept access to shared storage and recognize that it's data that is being shared between different programs, and capture that data and play it back. Probably the biggest surprise for me was pointers. This customer made extensive use of COM areas before channels and containers came along, and they'd got round the 32K limit by, instead of passing the payload in the COM area, they would pass pointers in the COM area, and those pointers would typically point to shared storage. VTP is able to recognize that a COM area or another data area contains pointers, and is able to capture the data that those pointers refer to. Moreover, those pointers can be chained. So if one data area points to a second data area, and that also contains a pointer, the product is able to chain along a number of pointers and capture all the data that is chained together. And finally, yeah, sure, yeah.
Sorry, I've got a question in the chat. It's come to me direct, so Nick, you haven't seen it, but it's from Elaine. I think we're all at the stage probably you were at, you know, oh my goodness, is this just a playback thing? And obviously it's not, it's far more sophisticated. Does it support BDAM files is Elaine's question. I'm not quite sure how CICS interacts with BDAM.
Yeah, you've got me as well. If it's an exec CICS command, and I think it is, then yes, the answer is yes.
Okay. And while we're at, we've got another question from Sharon to ask if static DPLs are covered.
Yes, both static and dynamic DPLs are covered. So essentially, if program A DPLs to program B in a different region, it will recognize that they're part of, although they're running as different transactions in different regions, it will recognize that they have logically the same transaction, and record the COM area or channel interface between them both. Yeah,
and I've got a follow-up question from Elaine. BDAM in batch. So you've thrown me there. That's if.
Oh, great! I get to throw that one to Joe.
Steve as well.
I get to throw that one to Joe since it's batch. So Joe can look up the knowledge center while we continue on that one. Hopefully, we'll get an answer before the end.
Is that question coming straight to you then? Because I don't see.
Yeah. Elaine, could you just forward that on straight to Joe?
Please, yeah, that'd be a direct
message, and Joe look it up while we're talking.
If you're allowed to share your email, feel free to do that. I can get back to you afterwards.
Yeah.
So in summary, at the beginning of this POC, as I say, there was multiple things I thought this product wouldn't be able to cover, and in the end, by and large, it catered for everyone. So I think, if Joe's not looking up the manual at the moment, this is probably a good time to actually do a demo, because I think a demo will be able to illustrate some of the things we've been talking about. Joe, you ready to do the demo?
Yeah, I'll do the manual after the session.
Yeah, I'll stop sharing if I remember how to do
that. Oh gosh, my camera looks blurry. Right, let me share the right screen. I think this is the right one. Okay, can I just get confirmation you can see my screen, if that's okay?
Yes, Joe.
Okay, good. Right, so let's walk you through a demo. So I've got what you see right now on my screen is a Jira ticket. For those of you not familiar with Jira is essentially a workflow management tool where you just define tasks and user stories and all these agile terms. Basically tell developers to do stuff, right? So in this ticket, you can see where I've highlighted, we've got the CA date of birth does not show correctly in the inquire customer transaction and API, right? So we've got a diagram that has scanned the source code and also the West Connect API. I won't talk about the products. I don't want to make this a product pitch, but this static code analysis has shown me that we've got an API that comes into this program here, comes to this program LGIC DBA1, does a select query from the customer table, and there's something about the date of birth that is being manipulated by this program that is feeding back to the API. So I'm going to close this. And what I'm going to do is actually look at that API call. So we've got the API call here in dev. Open that in a new window. And if you can see that we've got for customer number 1, the date of birth is obviously incorrect unless we're living in the past. If I put in customer number 2, we've got the same problem, right? So coming back to the ticket, if I click on the second graph, I'm going to zoom in where we believe our analysis tools identify where the problem is occurring, which is in this program here. This program is the same program that we saw before, doing a select query from the customer table. The date of birth has been manipulated somehow, and this funnels all the way up to back to the screen, right? So we've got a terminal interface and we've got an API, right? Why is that important? Well, because we are going to record this defect in a pre-prod environment or test environment, wherever we can reproduce the error, and then distribute it out to our developers to debug that transaction and find out where the issue is and fix it. So I'm going to just put this to the left here, and I'm going to go into my CICS test system, and I'm going to just clear screen. Right, so I'm going to show you the, I'm going to show you the terminal interface. You saw the API. This is the SSC1 transaction, which we saw here, right? If I give customer number 1, right, there's the defect that we saw. So let's talk about the product. So I can record in 2 flavors. I can record from the API coming into the CICS region, and I can record for the terminal screen. I'm going to quickly show you both. So BZUT means T for transaction. BZU is just the high-level qualifier for the product name. So when I do BZUT...
Yeah, Joe, sorry to stop you. I'm not sure we're seeing the right screen now. We're seeing a screen from you, but not the one that's changing. This one's got a... There we go. That looks better.
Can you see...
A lot of coloured blobs, like a flow chart with GIF, front of everything.
That's the wrong screen. That's funny, isn't it?
Cool.
It's a good thing you spotted it.
It wasn't me.
All right. All that intro. Anyway,
I'm trying to work out some questions for the next session.
Okay. Right. So. Okay. Hopefully you can see the right screen now.
Yeah, I can see the green screen now and the cog with CICS in it.
Right. Okay. Right. So you didn't see the API or anything. But anyway, so right. What I showed you was that there's an API call, and we've got this defect where date of birth has not been shown correctly. Right. So, so there's 2 ways I can record. I can record from the API or the terminal screen. So I'm going to record from the API. So I do BZUT, which is to record from the API, and I can do CSMI. Why CSMI? Because that API call comes into this CICS region with CSMI. So if I do that, start recording, and I go back into my API call here, right, which is there, and this is the defect. I'm going to run that. Right, I've already triggered that off, and I'm going to stop recording using BZUE to end recording. Okay. If I do BZU now A to write out that data, it's recorded all of the input into the CICS region from the API call, the program to program calls, the program to subsystem calls, and all the data going back up to the screen again. right? And that was 10 records stored in my TD queue, right? So that was one way of recording, and then I can stop the queue, distribute, copy the TD, the sequential file, send that to my developers. The other way is to do terminal recording. So if I do BZUS, S for start terminal, I guess, or terminal recording. I don't know what the S stands for, but this is terminal recording, right? And then if I do SSC1, which is the transaction, so we go back here, that cog is the SSC1 transaction. We're now at the screen. I'm going to select customer number 1, and then customer inquiry, which comes into this program here, LGIC US01. Right, recorded that defect, which got data, called the LGIC DB01, got data from the table and all the way back up to the screen. And I can do BZUE to end, and then BZUW to write that data out to my TD queue. Okay. Now I've got all that data in a TD queue. I've stopped the queue. I've copied the sequential file, and I've given it a name called date of birth defect, right? So, obviously my workspace is down. 1 second. You got to love live demo. Let me just start my workspace again. So now what I'm going to do, I've already done this already. I'm going to deploy that sequential file to my OpenShift environment, where I've got my real ZOS environment running, which is the AD/CD stack. If you don't know about that, it's just basically a ZOS environment with a basic ZOS environment without CICS or DB2 configured. So just to reinforce the point that I can test this transaction without all that middleware setup. And I've also, in my OpenShift environment, is basically I've got my own IDE running in there as well. So what you're seeing here is me booting up a browser-based IDE to enable me to do my debugging and find out where this debug issue is, or this transaction defect is in the transaction. Sorry, lost my words there. So that might take a few seconds to boot up. Whilst that's booting, if there's any questions in the chat or any questions, feel free to fire them away.
I think we're all kind of back where Steve articulated. It's the sort of, it looks really exciting, but the what about type thing. So what about we're a big web services shop, so transactions that come in via web services that run in the background that don't have a terminal to attach to.
Yep.
What about those?
Yeah. So so let me just show you that. And so you can record transactions coming into the CICS region using a different recording mechanism. So what I just showed you here was BZUS, right? BZUS is when you're doing terminal recording.
Yeah.
Now, if I change that S to a T, I can then specify the transaction that I want to record that's coming into that region.
Okay. Yeah, we have some similar sort of CDX, CDF type transactions that work like that. So yeah, I get that.
Yeah. So for example, I just did CSMI, which is ZOS Connect, start the recording. As long as my API comes into that region, I can record everything, the flow all the way through. And then
and say there's an orchestration of transactions. We issue that command for each individual one, or does it do one at a time?
We did test this, didn't we, Steve? I think it does.
Yeah. So that was a couple of ways of doing it. That I mean, Joe's recording CSMI there. That transaction ID can be wildcarded.
Yeah.
So if a wildcard is appropriate to capture all the transactions, you can do that. Or you can just issue that command multiple times. If you want to record multiple transactions with different tran IDs, just start multiple recordings and it'll record them all that way. They all end up in the same playback file.
Yeah, that's great. Thanks.
No probs. Right, I think I'm up. Right, sorry about that. I like using these browser-based IDEs, and it takes about 30 seconds or so to boot up. Right, so you can see here we've got IBM user defect .defect.dobs. That's all that recorded data. As I said, it's proprietary, it's sort of scrambled with our own sort of proprietary scrambling mechanism, right? So you can't quite read that. Now, what I'm going to do is actually debug this transaction, and I'm going to show you the job that I'm going to run. So this is this the right one? That's probably the wrong one. Where's the right one? Defect. Yeah, this is the one. So this is my ZOS environment, my personal ZOS environment, and you can see I've put in the load module for where the load modules are for the transaction alongside the defect, where the defect is. And here,
I don't think anybody else, but I'm finding it hard to read that. You able to?
Oh yeah, sure, yeah. Is that better?
Yeah, that's better. Yeah.
Good. So this is my this is where my load modules are for that transaction, which has been deployed to my sandbox environment. Here's all the recorded data, which is what we renamed to IBM user.defect.dateofbirth. And here is my debug palm that I'm going to run with, right? So before I run this debug session, I just want to really re-emphasize that this is a CICS transaction that we're going to run in batch without any CICS environment. So I'm going to go to my view. I need to set my debug profiles up first. So this will just BAU. So I'm going to go to my set open debug view. I'm going to create myself a profile. I'm going to create myself a batch debug profile. I'm going to debug the modules that begin with LGI asterisk, because that's the naming convention we've got for the inquire customer transaction. Right, I'm going to set my debug profile on. Okay, so now that's working. And I'm going to go back to that JCL and I'm going to run it. So this will now run the debug session. And if I go to my debug perspective, I'm going to click play. I need to put in my RACF ID for my sandbox environment. And now we are in the program, right? This is the, well, I'll say the program, the transaction. So I know the program where the defect is a program called LGIC DB01. So I'm going to do a Control F and do LGI CD DB01. I'll look for the exec CICS link call, which is right there. I'm going to set myself a breakpoint. I'm going to just go straight to that breakpoint. I'm going to step into that program now. Okay, so now I've stepped in. I'm going to set myself a watch expression because the problem was in CA-DOB. I'm just going to double check that by looking at the ticket again. So I'm going to switch the ticket for just 2 seconds. I'm going to close this. And it says CODOB does not show correctly in the acquired transaction. Okay, so I'm going to go back to my debug session and click watch expression. And then we're going to step through the code. So we're stepping through the transaction still. It's a bit tedious, but hopefully we can find out where the error is. All right, so you can see we've got a watch variable and it's watching and the value is 1950-0713. And then we can see there's some rogue code there that is changing that to 2950. Okay, obviously it's fictitious, but it's just trying to illustrate the point. Now I was able to find the defect. Now, assume that I've found the defect and I fixed the defect and then built it. I'm now going to rerun. I can then rerun my debug session just to prove that I fixed it, or I can just run the VTP job without the debug and then look at the mismatches, right? Look at the differences, which will come up in the report. So I'm going to do that approach just to show you a different flavor of it. So I'm going to go back to close this down. I finished the debug. I'm going to stop, inactivate my debug profile. Okay, I'm going to go back to my JCL. Just tidy this up a bit and get rid of these. Close these all down. Right, I've got another piece of JCL which has got the fixed executable rather than the the defect, which is this one. It's the wrong one, this one. Right, so here we've got the fixed load module in this load lib. We're still using that same recorded data, but I've got the debug palm in there, but my profile is not set. So it should just run without trapping the actual application. So I'm going to right click, submit this job. Okay, and just look at my job. So there's the job. So we're going to locate that job. Still running. Let's give it a sec. All right, let's give it 1 more second. There we go. Right, so we got a return code 4. Now, the reason why I want to put some emphasis on the return code 4 means that, hey, based on your code change, we found some differences, and it's for you now to have a look and verify if you're happy with those differences. So if I click on that, that job and then click on BZU messages, that's the report where it will highlight the differences to me. Now, at first glance, that could be a bit daunting to look at. We do have a VTP viewer to make this look a bit more slick, a bit more easy to read. But let me explain it to you. So here it's saying that for LGIC DB01, we recorded in the COM area from that captured the data from DB2, 29500713. Right, that was the rogue date of birth that we found in the program. Now, after your code change, we now notice that it's 19500713. That is affected then by the program that goes back up to the screen, which is LGIC US01, right? The COM area again was recorded with 295007, but the program has now got 1950, and it goes all the way up to the send map to LG test C1, where we recorded 2950, but now the map has been sent back with 1950. So that coincides with, just to really illustrate the point, that coincides with the transactional call graph, right? So basically, if we start from up here again, it's basically saying from the data coming back from DB2, this customer table, the COM area is different, which goes back up to LGI US01 and then back up to LG test C1, right? And then as a developer, I can say, you know what, I didn't expect that, or I did expect that, and I'm glad it's highlighted to me, and I can use this report as proof that I've done my quote unquote shift left integration test before I deploy my code to an integration test environment. So that's really the demo I wanted to show. I've really had to whiz through that quite quickly. The last point I want to just raise is that I've now integrated this into a pipeline. I won't show you the pipeline because it probably takes probably about 10 minutes to run. But what it does is that using Git, I can run that whole VTP process via a pipeline. So I won't talk you through the details, but what happens is that I will check my code back into Git. It will build my change code from Git. It will identify the recording that will set for me as part of this development project or this sprint or this release. It will run the test. So it got execute integration test here. It will run the integration test that you just saw. It will produce the report in the actual Jenkins viewer. And then it will ask me as a developer to review it. So Jenkins will call out to me and say, by the way, you just checked in this code. I've run the VTP test based on what your development manager has set for you. Can you review this report? So Jenkins will pause and then wait for me, the developer, to review it. And if I'm happy with the output, I give it the thumbs up, then great. I can then deploy it to the next environment. If I'm not happy, as in this VTP test hasn't really satisfied me based on my code change, then I can say no, and then it will package that binary, deploy it to dev, do a new copy into the CICS region, and then I can go for the traditional way of testing my CICS transaction. right? So that's just something I've been working on for another customer who's interested in this capability. I think that wraps me up. We've got 10 minutes, I think, for any questions, unless there's anything else you want to cover, Steve.
No, I think we'll just throw open to questions before we conclude. I've just been looking at the doc while you're talking, Joe.
There's a couple of questions in the chat. That's kind of waiting for Nick, but he's
I'm here. So Ian Titford has asked, how does it play with other global user exits? Any considerations?
So yeah, good question, Ian. So honest answer is I don't know. That there's obviously techniques for ensuring your global user exits don't interfere with other vendor or user exit programs at the same exit point. I would hope VTP plays well with other user exits, but we haven't tested that, so I can't say for sure.
No, we haven't.
Okay, thanks, Steve. And another one from Melvin. If a screen has a current date time, will this always show as a change?
Oh, there is a way to avoid that, actually, that was introduced in 2.0. I don't know the details of that, but in short, you can ignore date and time timestamps, and you can also change date and time timestamps that is recorded in the playback file.
Okay, thank you. Ian has a follow-up question. When tracing a program, can watched variables be dynamically changed, e.g. made correct or incorrect?
I'm not sure I understand the question.
This is something our developers do when they're using a debugging tool, for example. They're trying to test paths through the code. So, you know, a variable might be Y or N, and you branch on that logic. And they might manually just step through the code and change a yes to a no so that it branches to another instruction dynamically.
You can only do what has been recorded. So if you haven't recorded those journeys, then you won't be able to do that. Cool. So the one thing I will say to you, although we showed you one application journey that we recorded, you can record multiple application journeys. Now, how that corresponds to a debug session, I do not know. I haven't tested that, but I'm sure I can look into that and get back to you.
I think I've taken Ian off mute. So Ian, does that answer the kind of spirit of your question? Is that what you were after? Or have I not managed to unmute you? If you're unable to use audio, just type in something into the chat, Ian.
Oh, I can see he's put data stores here as well.
Yeah, his mic's broken.
Okay, so yeah, okay. So we got data sources like TSQs, document, DTP.
Okay, I'll take the data sources question. So I think what Ian's asking there is exec CICS commands for TSQs, the document API and DTP supported. So they are all supported for recording. The more interesting question is what will happen at playback. So TSQs I think are straightforward. Yes, the VTP will record what is written and read from TSQs and can play that back. Likewise with the document API, DTP is a more interesting one. So we'll record DTP conversations. So exec CICS send, so essentially this is two tasks in two different regions doing sends and receives to each other. So it will record those. However, when you play that back, it won't detect that it's actually a DTP conversation that program A and program B are communicating. So I won't be able to tie up the program send, the exec send and program A with exec receive and program B, and detect that if the send changes in program A, then the receive needs to change in program B. So I don't know if I've ever really answered that, but in short, it will record successfully, but it doesn't give the same level of capability as DPL, for example. With DPL, it knows program A and program B are communicating via a COM area or a channel, and it will detect any differences. It won't detect differences for DTP.
So there's a follow-on from that. Can you record these areas as well?
Does it go yes, so BZUT TRN1 will record every instance of TRN1, yep, until you stop recording.
Yeah, and I just answered that one in the chat, and
Okay.
there's a new one called BZUX, which I haven't had time to try out yet, but BZUX can actually limit the recording for a transaction up to 10 times. So you can also use that, but I haven't tried that yet, but that came in new, the product recently.
Thanks, Joe.
Well, we're nearly at the end. There were lots of questions here, and I'm sure there'll be a few more. I'm certainly very impressed personally with it, and I suspect we'll be asking for a demo as a customer, because this product definitely looks like it's got legs to me at that sort of initial stage of testing space. So thanks, Steve and Joe, for a brilliant demonstration. This is what GSE is all about. And hopefully the people who've been on the call, you can take this away to your companies and have a bit of a think about it. I know we're definitely going to. And thanks for your time. Good to get a question as well from Ian and Melvin, just mentioning that the 10:30 slot and awkward questions to Hersley. Melvin, you were the master of that. So hopefully we're going to channel a bit of inner Melvin later on at 10:30. If everyone could feedback on this session, I think it's been a great one and worthy of some decent feedback. And I'll see you all in half an hour. Thank you so much again, guys. Really
Just before we go, so as part of the panel for the Q&A, we've got the CICS Development Director, Steve Wallin, attending. We've got the Distinguished Engineer and Chief Architect, Fraser Bone, attending. I've got Ian Burnett coming in from who's kind of a surrogate Ezreal, because it's a little bit early for Ezreal to get up in the morning to make it. So Ian's our test architect, performance architect, and really what he doesn't know about tuning isn't worth knowing. We've got the speakers that have been here all week, so it is a great opportunity to actually speak to the experts on these. Thanks, Rob.
Right, you've given me another ammunition for another awkward question. Thank you so much, Nick. I'll write that one down. In a DPL bridge question coming on now, Mr. Burnett, so that'll be good. Okay. Thanks very much again. Give you all time to get a coffee. I know I'm going to go down and grab one, and see you all in a bit. Cheers, everyone.